Okay, as I wrote on WhatsApp, I am a little disappointed by the quality of work that you did in these problems, but I will now show you the correct answers, the corrige, as well as actually show you how to solve these problems, how to write them neatly so that they're easy to read, so that you tend to make fewer mistakes. We'll start with the simplest one. This was this problem here, comparer des périmètres et des aires. You had to compare the perimeter of this rectangle and the perimeter of this shape, and you have to compare the area of this rectangle and the area of this shape. And so, and here Anna said that the perimeters of both of these is the same, and Bryce said the areas of both of them is the same. You have to say whether Anna was correct or wrong, and you have to say whether Bryce was correct or wrong. Now, there are two things. One is we will see the correct answers, and we will also see how to solve them. I've also taken printouts of some of your submissions, and I will use them as examples to show you how not to solve these problems. So let me start with this. This is one of your submissions, and the entire problem is in these 3 lines. Sorry for the scan and the printout, but still I will read. L'affirmation d'Anna, I assume that's Anna, et Brice ne sont pas vrais. This answer itself is wrong, but car this is not equal to this. A little difficult to read, but especially in the this is not equal to n'est pas égal à this. So this one of you, this was the entire submission for this problem. Now, if you are going to say that this expression is not equal to that expression, first of all, show it. Why do you just leave it like that for me to calculate it? Secondly, you don't tell me what this expression is. You don't tell me what this expression is. How am I supposed to know what you are doing here? So don't get disappointed. I'm not scolding you. I'm just showing you how you should do it. So in future you do it better. And let's take this problem exactly the way you should do it. So first I've drawn it. This is 5. There are then 3 squares of equal size, x, and similarly here this is 5 minus x, this is 2 times x, 2 times x, 2 times x, then that little bit is x again, and this is same as x. So let's calculate the perimeter of this one. So the perimeter of this is 5 plus, how many x's are here? 3x. 5 plus x plus x plus x, which gives us 5 plus 3x. And what is the length of that side? That is x. So this is x plus 5 plus 3x is the length of 2 sides, 2 adjacent sides. You multiply the whole thing by 2 to get the entire perimeter. You see, I just put another set of brackets and multiplied by 2. Of course, I could have written twice on this side, but I've written 2 there. Then you develop it. So I open the inner brackets, I get x plus 5 plus 3x is equal to 2. That gives me 5 plus 4x. Where do I get 4x? X plus 3x. 5 plus 4x into 2. That gives me 10 plus 8x. So the perimeter of this rectangle is 10 plus 8x. Now let's take the perimeter of this diagram. And here, because it's not a rectangle, we can't just multiply by 2. We will take this plus this plus this plus this plus this plus this. We will add up all these 1, 2, 3, 4, 5, 6 sides that constitute the perimeter of this particular figure. So let's take the long side first. It is 5 minus x plus 2x. Because this is x and x, so it's 5 minus x plus 2x. Then we take this vertical bit, that is 2x. Then we take that little top horizontal bit, that is also 2x. Then we take the little vertical bit there, which is coming down, that is x. So 1, 2, 3, 4 sides, it comes to that. Then I run out of paper. So now the way to do this is, when I run out of paper, so is to write it like this. Then I write this bit here, this horizontal bit there, that ledge if you might call it, is 5 minus x. So you add another 5 minus x, and this final vertical bit is x. So you see how I've written it. It's clear. This is, if possible, you should avoid writing an equation across two lines, but if not, this is the way to do it. So now let's develop this. This is very simple. If you open the brackets and you count, it'll come to 10 plus 6x, because there's 5 and 5, those are the only non-x terms. All the others, if you add up, 2x plus 2x plus 2x gives you 6x, minus x plus x cancels out, minus x plus x cancels out, you get 10 plus 6x. So then you write here, affirmation d'Anna est fausse. This is not equal to this, donc affirmation d'Anna est fausse. See, this, if I do this, if you do this, it's so easy to understand. If I have to look at this, how will I understand what's going on in there? Okay. Also see the amount of white space I've used. There's so much white space. I have not tried to cram things into just into tiny areas. I've kept white space between the lines also, so that I can read it clearly. Okay, let's do the air. So air is simpler here, because this is 5 plus 3x on this side into x. So air is 5 plus 3x into x. If you do the multiplication, open the brackets, you get 5x plus 3x carré. That's it. Air is 5x plus 3x carré. Now this side, the perimeter of the air of this figure, you have to take in two parts. This is a square, 2 by 2 square, 2x by, not 2 by 2, it's 2x by 2x, 2x multiplied by 2x. This is the square, and this rectangle is 5 minus x into x, that is this area, longer for larger. So let's come down. So I will write it as two things. Air, so I'll write partie rectangle, A rectangle, A air est égal à 5 moins x fois x. 5 moins x fois x, ça nous donne 5x moins x carré. 5x moins x carré. Okay? Now let's take the partie carré. The partie carré is 2x into 2x. That's very simple. Partie carré, AC, A carré, 2x fois 2x, 4x carré. Air total, AR plus AC, 5x moins x carré plus 4x carré. Ça nous donne 5x plus 3x carré. 5x is there, moins x carré plus 4x carré, 5x plus 3x carré. See, I wrote air total and then I wrote air plus AC here. If I had omitted that step and written directly here, then it would have become more complicated for you, for me to understand what I am doing. So always write in detail. So then we can see this is equal to this, affirmation de Brice est vrai. Okay. So this is how you have to do this entire problem. Okay. So that is for this problem. Now let's come to the next problem, problem number 89. This one is called Imaginez une stratégie. Deux nombres en pourcent 300. De combien augmente leur produit? Produit. One of you did this as the sum. Please, produit is multiplication. Si j'augmente de 7 chacun des deux nombres. So, conjectuez la réponse à cette devinette après avoir choisi des nombres dont la somme est 300. This means just try it out. First see what the difference is. So let's take that. Here we take an example. So A est égal à 50, B est égal à 300 moins 50, B est égal à 250, because both of them have to add up to 300. So see, I'm talking quite fast. You can slow it down, you can pause, because we have 5 problems to get through, and we can see how, and you can pause and if I go too fast and resume. So A fois B, 50 fois 250, you do that in the calculator or in your head, it's 12,500. Then you add 7 to each number. De combien augmente leur produit si j'augmente de 7 chacun des deux nombres? So it will become A plus 7 into B plus 7 is equal to 50 plus 7 into 250 plus 7. See, I've written it all out. I didn't directly write this step. I wrote first this step. So now what is this? This is 57 into 257. You multiply it. This you do on your calculator. You get 14,649. So difference is 14,649 minus 12,500. Difference is 2149. So now let's take another two numbers. Soit A est égal à 100, B est égal à 300 moins 100, 200. So I'm taking two numbers, 100 and 200. This is what you have. Many of you have done. They've taken these two numbers. A fois B, 100 fois 200, 20,000. A plus 7 into B plus 7, 100 plus 7 into 200 plus 7. See, again, I have not written here directly 107 and 207. If I write values, variables, then and I replace them with numbers, then I write once at least what numbers are being used. If I wrote directly 107 there, you would get confused. What is A? So 107 into 207, you get 22,149. Your difference is 22,149 minus 20,000 is 2149. Some of you have said that you have tried 2 or 3 numbers because the difference is 2149. That is, you can take any two numbers with the differences with the sum of 100. When you add 7 to each one of them and multiply, you'll get 2149 as the difference. This we have seen in two particular examples, but in mathematics this is not proof. Examples are never proof. What if you took another two numbers and you tried it and it didn't work? So you have to, and that is what 89b says, imaginez une démarche pour prouver cette conjecture dans le cas général. That means in a general case where you don't choose actual numbers but you only choose two numbers where you know a plus b is equal to 300. But you don't actually take values of a and b as given values. Only that their sum is equal to 300. For example, this is like saying that if you add any two numbers, the sum is always 8. What? Yeah, the sum is always 8. Any two numbers you add. See, if you add 3 plus 5, you get 8. You add 2 plus 6, you get 8. You add 1 plus 7, you get 8. You add 1.5 plus 6.5, you get 8. So any two numbers you add, you will get 8. Obviously wrong. Just because I gave you so many examples doesn't make it a proof and doesn't generalize the case. So, how do we do this? Imaginez une démarche pour prouver cette conjecture dans le cas général. So, there are two ways of doing it. One is a slightly elegant way and one is slightly simpler way. Ritul did the elegant way and we'll start with that first. Soit deux nombres a plus b et soit a plus b est égal à 300. Now, we are not giving these values, we just know this. Okay. Quel est le produit de A et B? A fois B est égal à AB. That's all we can say at this moment. We know nothing more. We don't know the numbers. We don't know A and B, so we cannot tell what exactly this value is. We just say it is AB. Then if we take A plus 7 for B plus 7, which is what the hypothèse is, that is how you have to take it. Si j'augmente de 7 chacun des deux nombres, then what do I get? Now we will develop this. So first I multiply A into B, I get AB. Then A into 7, I get set A. Remember, we don't write A set, we write set A. Always put the number first. It's only a convention. It doesn't mean it is wrong if you write A set. People will only get confused. And then I multiply set for B, so I get set B. Then I multiply set for set, and I get 49. So when I develop this, I get this. Can I simplify this? No, but set A plus set B, we can factorize it. And that's the elegance of this particular proof. This is what Ritul did. None of the others did it this way. You did it the other way, if you did it at all, that is. So what he did was, he did set A plus set B est égal à set fois A plus B. So this is equal to AB plus set fois A plus B plus 49. Why did he take that? He took that because he knows A plus B est égal à 300. So, when you do that, he wrote AB plus 7 fois 300 plus 49. So when you expand this, when you multiply that, you get AB plus 2100, 200, 2100, pardon, plus 49. So that gives us AB plus 2149. What's the difference? Well, the difference between AB and this is 2149. Without knowing the values of A and B, you have proven that if you add 7 to each side, 7 to each number, and then multiply it, you'll get a difference of 2149. This is amazing. You have proven this. So then it means that you can actually generalize. This is proof because this is not an example. Différence AB plus 249 moins AB est 249. So now just to prove to me that you're watching the video, you have to do two things. Remember this A and B there is nowhere the specification that A and B have to be positive. There is no specification that A and B have to be integers, that means nombre entier. So you give me two examples where A or B, one of these is negative, but this condition is true, and then you work out whether the difference is actually 2149 if one of these numbers is negative. You just calculate it. Don't try to prove it like this, but just calculate it like here. Okay? So that is one. And the second one, take two numbers where they are not integer numbers, they are not nombre entier. You can take 100.5 and 199.5 or two different numbers and see whether you still get the same thing. Again, you do it with the calculator because we have already proved the general case. You are just confirming that the general case also applies to if one of these numbers is negative. I'm saying one of these numbers because if both numbers were negative, they won't add up to 300, they would add up to some negative number. But if one number is negative, the other is positive, you can still have the sum as 300. And the second example you do for one of these numbers being, or rather both of these numbers not being nombre entier. Okay. Now we'll come to how to solve it without that elegant way. This is the way the book's corrigé has shown it. So we have two numbers, A et 300 moins A. We don't say A and B, we just have one number A, so the other number is obviously 300 minus A. So now when I do it, so what is the product of these two numbers? What is, if we multiply this, so if I do that, it will come to A into 300 minus A, it is 300 times A moins A carré. So this is the product of these two numbers. When you multiply these two numbers, you will get this. Okay. Si on ajoute 7 à chaque nombre, le produit sera A plus 7, and then you have to add 7 to this, 300 moins A plus 7, which is equal to A plus 7 fois 307 moins A, because here 300 plus 7 you can add, gets 307 minus A. When you multiply this and develop it, you'll get 307A, then moins A carré, A fois moins A, then 7 fois 307, 7 fois 307, moins 7A, 7 fois A, 7 fois moins A, moins 7A. So, here what can you see? 307A moins 7A, ça nous donne 300A, moins A carré, plus 2149. Again, you see this 300 minus A square is the same as 300 minus A square. So this is the difference, again, is this whole thing minus that 300A moins A carré plus 2149 moins 300A moins A carré. So if you open these brackets, this will become moins 300A, that will become positive, minus minus positive, A carré. Moins A carré plus A carré will cancel out, and you will get finally 2149. 300A minus 300A again will cancel out, you will get 2149. So this is the standard way of doing it. You do it like this. You have again proven that if you take two numbers, sum is equal to 300. You add 7 to each number and you multiply them. then the difference in products will be 2149. Okay, so this is problem 89, and let's come to the next problem. So this is the number 90. Here you have to just verify that this is correct, find a pattern, and then Adeline affirm that this is correct, comma Patel anath certain. How can she be sure? So this is very simple. The first thing we do is we find a pattern. So we see 1 into 3 is equal to 2 square minus 1, 2 into 4 is equal to 3 square minus 1, 3 into 5 is equal to 4 square minus 1. So what are we doing here? We see this, if we take this number as n, then this number is n plus 2, the difference is always 2. This number is in between them, 3 and 5, 4, 2 and 4, 3, 1 and 3, 2. So that is n plus 1 squared minus 1. So you see these are the three numbers, and the pattern seems to be alors il faut voir si n fois n plus 2 est égal à n plus 1 au carré, n plus 1 au carré moins 1. So now let's take this particular expression, n plus n fois 2. When you multiply it, you get n carré plus 2n. We take this one and we expand it, you'll get n plus 1 au carré moins 1. Expand is same as develop it. So let's write that out, the whole thing, n plus 1 fois n plus 1 moins 1, that moins 1 is from there. Let's develop this, you'll get n carré plus n plus 1 moins 1. Here you'll see the plus 1 moins 1 cancels out. The two n's here, you get n carré plus 2n, which is the same as that. Donc, on peut affirmer que n fois n plus 2 est égal à n plus 1 au carré moins 1. I'm sorry, that should be a multiplication sign there. There. It should be multiplication. Okay. Now we turn the page. Donc, Adeline peut affirmer, she takes two numbers, 100,005 into 100,007 is equal to 100,006 square minus 1. Here she has taken n is equal to 100,005. So here also, just to show me that you've been watching the video, you do two things. You do one thing rather. Here you take a number. Again, we have seen that this doesn't necessarily apply to integers. It can apply to fractional numbers also. So you please do this for two numbers which are, so can you take two numbers which are not integers. Take, say for example, 4.5 and 6.5, and you show that this is equal to, what is it, 5.5 squared minus 1. See whether this works. Just verify this on your calculator and let me know. This is also true. If this is n plus 2, this is n plus 1 minus 1. That is the pattern we have found there. Okay, now I'm getting tired a little. We have been speaking for 24 minutes already. You've been watching it, and see, now you see how I've done it here. I'm again going to show you some examples of your work. Now this is one of you. I mean, how am I supposed to read all this? There are arrows, there are all these funny lines. Try to avoid all of this, because you've written here x into 300 minus y. This says 2 here, or z, I'm not entirely sure. I'm not really sure what you're doing here. So do not use expressions, do not use signs that are not in mathematics. Occasionally it's okay, like once I did here just to show that this is n and this is n plus 2 and this is n plus 1. But I'm not going to be able to understand what's going on here at all. And look, if you submit something like this, I'm not even going to try to understand because it's so complicated. Why should I even follow what you're doing here if you don't explain what you're doing here? Okay, so please try to do it systematically like I show you. And look, this whole page, I'm turning it around. No, so I can't do that, sorry. This whole page, when I see that, you see how much white space is there, how easy it is to read. So that's what I want you to do. And look at this. Look at this. I'm supposed to read this. Par Antoine, on sait que sœur égale x est égal au frère, soit f frère est égal x plus 1 et par something phi frère est double du nombre en sœur sauf elle. Donc on écrit x, that's an arrow, x plus 1 est égal à 2x fois, can't even read it, x moins 1. Maintenant, on aurait dit x moins 1 égale frère, alors Astrid parlait de ses sœurs et pas elle, donc le nombre de garçons son père, et donc x plus 1 sera un nombre impair. See, it's very, very difficult to understand what you're thinking, what you're writing. Don't write like this, write like this, write clearly. And coming to this Antoine Astrid problem, we will do it right now. Okay. So how do you do it? You can do it in two different ways. One is with one equation, one unknown, and the other one is two equations, two unknowns. I happen to know that you were taught last year how to solve two equations with two unknowns. So we'll start with that. Okay. Soit G, fille de Rose. Soit B, fils de Rose. These are the number of girls she has. These are the number of boys she has. I've written G and B because if I write F and F, they're both Phi and Fis start with the same letter. So I've written G for girls, B for boys. Correct? Okay. Nombre de sœurs d'Astrid. Astrid is a girl. How many sisters she has? Well, she has sisters. She can't count herself. So she has G minus 1 sisters. Correct? Correct. Nombre de frères d'Antoine. B moins 1. He cannot count himself. So number of boys minus 1 is the number of brothers he has. Okay, now let's come to the two equations. Here he says, where is this, number 92? Sorry, I have to turn the page here. This probably be the longest, oh here it is. This probably will be the longest video I've ever made. Okay, Astrid dit, j'ai deux fois plus de frères que de sœurs. So that means, take the number of sisters, multiply that by 2, that will equal the number of brothers she has. Take the number of sisters she has, multiply that into 2, that will equal the number of brothers she has. Okay, so let's take that. Nombre, so we come to number of brothers, number of boys. So the number of frères, number of brothers she has is the number of boys that Rose has, number of sons of Rose. So that is B is equal to 2 times G minus 1. G minus 1 is the number of sisters she has. So B is equal to 2 times G minus 1. This is equation 1. Then Antoine says, j'ai autant de frères que de sœurs. So how many frères does Antoine have? He has B minus 1. So he is saying that the number of sisters he has, which is all the daughters of Rose, G is equal to the number of brothers he has. So we have two equations. This is equation number 2. So what we do, par 1 from 1, we know B is equal to 2 into G minus 1. We can replace it. Yeah, so we just expand it a little. Sorry, we do both of those. So here we can say B is equal to 2G minus 2. We develop it. And here we make B on this side and we put G on the other side. So we'll get B is equal to G plus 1. How do I do this? I move the 1 on that side. So it'll be sign will change. It will become B is equal to G plus 1. But I write B on the left and G plus 1 on the right. So these equations are called 3 and 4. What do you see? B is equal to 2G minus 2. B is equal to G plus 1. So obviously 2G minus 2 is equal to G plus 1. From part 3 et 4. We get 2G minus 2 is equal to G plus 1. You solve this, You'll get 2g minus g. I take the g on the left, I take the minus 2 to the right, it becomes plus 2. I get g is equal to 3. This is the number of girls that Rose has, number of daughters Rose has. Okay. But we want to know the total number. But now we know g is equal to 3. We can plug it into this equation. Donc Rose a 3 filles. Par 5 et 4, on dit b est égal à g plus 1, which is I just copied this fourth equation here. G est égal à 3. I plug that in. I get b est égal à 4. Rose a b plus g est égal à 4 plus 3. 7 enfants. This is the way to solve it with two equations, two unknowns. Okay, so I've got another sample of your work. This is another sample of your work. One of you has done this. Don't have to read this, but I'm just showing you how much more difficult it is to read this. See, the answer is correct. Rose a 7 enfants. Anton a 3 et 3 frères et sœurs. I'm not entirely sure what he means there, but alors Rose, he means Antoine a 3 frères plus 3 sœurs plus himself. He has 7 children. Rose has 7 children. So, this is absolutely correct. But it's a nightmare to read. Because it says, look, let's look here. Alors, il y a 3 sœurs, 3 moins 1 sauf Astrid, alors 2 sœurs, frère est égal à 2 sœurs, 2 fois sœurs, donc 2 plus 2 égale 4 frères, 4 moins 1. This is not an English essay here. You know, you don't put an equal sign at the end of a line. You do write a simple equation, every equation on a separate line. Here, look, where have I put an equation at the end of a line and taken it over? Nowhere. Okay, so finally, what I do is, this is the alternate way of solving it without using two variables. We use only one unknown, that is, so f le nombre de filles de Rose. Here I am using f, not to confuse it with b and g. Why isn't it focusing? Yeah, there we go. So f le nombre de filles de Rose. Le nombre de filles de Rose, fils de Rose est égal à 2 fois f moins 1. How do I get that? That I get from here. Because she says, j'ai 2 fois plus de frères que de sœurs. So how many sœurs does she have? Astrid has f minus 1 sisters. Number of brothers she has is 2 times this. Number of brothers she has is the number of sons Rose has. Every one of the sons of Rose is her brother. So f minus 1 is her number of sisters, multiplied by 2, you get the number of brothers she has, which is the number of sons Rose has. And then we go to the next statement, j'ai autant de frères que de sœurs. So here, le nombre de frères d'Antoine is this whole thing. These are the number of boys, number of sons Rose has, and his brothers are going to be minus 1. Minus 1 why? Because he is not his own brother. So the number of brothers is all the number of boys minus 1. Okay, now we come to, now we say, j'ai autant de frères que de sœurs, autant de frères que de sœurs. So, sœur, he has f, frère, he has 2f moins 1 moins 1. So we get this one equation. See, from the first equation, from the first statement, j'ai 2 fois plus de frères que de sœurs, I got this. From there, I got this, nombre de frères d'Antoine. From the last one, j'ai autant de frères que de sœurs, I got this. Because this is the number of sœurs and this is the number of frères. You develop this, you get 2f minus 2 minus 1 is equal to f. You do 2, you bring f on the other side, you get 2f minus f. You bring minus 2 minus 1 on this side, you get plus 2 plus 1. So you'll get finally, just wait for me to for it to focus. You'll get f is equal to 3. It's not focusing. It will. F is equal to 3. Rose a 3 filles. Norme de Fils, 2 fois f moins 1, we had already seen that. So you get 2 fois 3 moins 1, 2 fois 2, 4. So Rose a 4 fils, 3 filles, 4 fils. There we go. Rose a 3 plus 4, 7 enfants. This is the way to do it. Now also I had asked you to do one more problem, and I'm sorry to say only 2 of you even attempted it. Both of you got it wrong. That was this problem, a plus b into b plus c into c plus a. I'd asked you to develop it and simplify as far as possible. Now the way to do it is you put a bracket here and you then do a plus b and then you solve this and then you simplify it. You develop it and you simplify it, and once you can simplify it no more, then you multiply by a plus b, that is a into each one term there plus b into each one term there, and finally when you get the whole thing you simplify it. So please do this also. So essentially I want you to do 5 calculations. This you have to solve, this is not a calculation, and the 3 other calculations I gave for the earlier problem. I'm going to stop here, my throat is dry. It's 37 minutes almost into the video, and this is what I want you to do for tonight. Let me see whether there are any other examples that I wanted to show you. Yes, this is one. This is the number 90, where you have to show that, So this student has written elle peut-être certaine. This is Adeline. Here, Adeline affirme que this, comment peut-elle être certaine? So elle peut être certaine car x fois x plus 2 est égal à x moins 1 au carré moins 1, donc Now this, first of all, breaking an equation across a line, no, please don't do that. This, of course, is what you have to prove. Have you proven this? No, you haven't developed this, you haven't developed this. So you have to develop this separately, then find if they are equal, then you can say this is equal to this. So this is what you have to do. And this is a most interesting answer to number 92. Rose a 3 enfants, car 2 fois 1 est égal à 2, et 1 plus 1 est égal à 2, donc 2 plus 1 est égal à 3. This is the entire answer of number 92. Please, really, I feel that I'm wasting my time if you do things like this. Anyway, small matter. Now do this, and I was going to do a video for chapter 4 today, but I will have to defer that to tomorrow. Tomorrow morning I'm going to be a little busy, so I'm not sure I will be able to post it tomorrow, but I will try. In any case, it's a very simple chapter. Here we are. It just has to do, it's called Utiliser les nombres rationnels. So first we will decide we'll define what is a nombre rationnel, and then we will say how you can compare two nombres rationnels, and then addition, soustraction, and somewhere there is a multiplication, division also. But we'll do that. This is basically dealing with fractions. Okay, I stop here. I'll try to upload this as soon as possible.